Well, hey, you guys. This week I'd like to talk to you a little bit about some geology principles that geologists use when they take a look at landforms and begin to try to figure out kind of what I call the puzzle of geology. So, remember when you guys were looking at your cupcakes last week? In a sense, that was a puzzle. You were wondering what was going on inside, so you did some testing, you collected some data, and then based on that data, you were able to make a prediction as to what you thought the inside of that cupcake looked like. Well, geologists do the same thing as they look at landforms, so they use different principles to help them do that. And for some reason, there we go. So one of the principles that they use is something that's called superposition. And if you take a look at the image on the right-hand side, you'll see that that red group at the very bottom, that scientists will tell us that's the oldest rock in that formation because it's at the bottom. On top of that is that green layer, and then that kind of yellowish layer in the middle, then that darker one near the top, and then you have the one at the very top. You may even recognize some of those words in there, the very bottom, or they just call it a supai group, and then the shale on top of that, then sandstone, and then another formation, and finally limestone on the top. So again, the idea is that the oldest material is placed on the bottom. On the left-hand image is what it really looks like in real life, which is kind of cool. Another principle that geologists use is what we call cross-cutting. And again, if we take a look on the left-hand side of this image, we have the oldest layer at the bottom, we have the next oldest layer in the middle, and we have the youngest layer on the top. But sometimes what will happen is, once that's already been laid down, a volcano may go off or be under the ground or on the surface of the earth, and that may push some material, some lava type material, magma, through that existing layer of formation of rock. So in this case, the material that comes through in the magma form is called a dike. We're going to talk more about volcanoes and some of their structures later. But the point of this is that the dike then would be the youngest rock material because the oldest layer, the bottom, was put down first, and then the next oldest was put down, then the youngest, and then the dike came through that. So that's how you can tell the age based on taking a look at that. And again, that's called cross-cutting. The next principle that geologists adhere to is much what you guys actually did by instinct last week with your cupcakes. And that was, you generally assumed that the layers were laid down horizontally. And if you take a look at this image, that's what geologists also believe, is that if you have a depression and we're putting materials in that depression, that given time and no other forces, then those layers will be laid down horizontally. If you take a look at the very top of this image, though, you'll see that it's not totally flat all the way across. That's because some erosion has taken place, and that forms what we call an unconformity. And that's a surface that represents significant gap in the geologic rock record due to erosion or long periods where no deposition was taking place. And that image down below there, you can see that line between the sort of reddish material at the bottom and that gray material at the top. It's not perfectly flat across there, it's bumpy, much like this one was at the very top. And that would be an area of unconformity. Then we also have erosion processes taking place. In the upper left-hand corner, that erosion actually came through the forces of both wind and water. Wind is a great eroding agent, as is water. Take a look at the upper right-hand corner. You can see how the waves in the water have acted on that rock and have eaten it away. That's what erosion is all about. The bottom left-hand corner, we had some rain, lots and lots of rain, perhaps a flood or something like that causing erosion. And finally, at the bottom right-hand side, we have some evidence of erosion from glaciers. And we see a lot of that around here, so when we're out and about, perhaps on our field trip, we might be able to see some evidence of erosion as a result of glaciers. Well, that's some ideas, principles that geologists adhere to, and we'll put that information to work when we meet again on Thursday. Thanks.